Welcome to the fourth video of Module 2 on solving systems of linear equations using substitution. Given a system of linear equations, as we have here, so x minus 2y is equal to 2 and x plus y is equal to 5, we can label them as equation 1 and equation 2. Our goal with substitution is to solve for the value of x and y that satisfy both equations at the same time, algebraically. And we do so by first solving for one of the variables in one equation and then subbing it into the other equation. Okay, so there's lots of choices that can be made here depending on if you want to choose by isolating x or y in equation 1 or 2, but as long as you perform the steps correctly mathematically, then you will still arrive at the same solution either way. Some solutions may be a little messier or just more involved than others, but there's really no incorrect answer. First, I'm going to solve for variable x in equation 1. Now that we have an equation for x, we can sub it into the second equation and then solve for y. You want to make sure that you substitute the expression for x into the second equation using brackets. So we have 2 plus 2y plus y is equal to 5. That will be particularly important when there's a coefficient in front of your variable. Okay, now we can simplify this. We get 2 plus 3y is equal to 5. And we're going to subtract 2 from both sides of the equation, and we find that 3y is equal to 3, therefore y is equal to 1. Now we use that variable of y, sub it back into equation 1 to solve for x. When we do so, we find that x is equal to 4. Therefore, the solution is 4, 1. In example 2, variable x is easiest to solve for from the first equation. Now we sub variable x into equation 2. This is where you can see how important it is to make sure you do the substitution in brackets. And we will take the coefficient of 2 and distribute it into the brackets, and we end up getting that minus 8 minus 4y plus 4y is equal to 8. And when we solve this equation, so grouping like terms, we end up getting that 0y is equal to 16, which actually has no solution. So there's no value of y that will satisfy this. And if we examine our original equations, these equations are of parallel but not equal lines. So they will never intersect and there's no solution. In example 3, we can solve for variable x most easily from equation 2. Now we want to sub that into the opposite equation, so we sub x into equation 1. When we do so, we substitute x in brackets and then we distribute the coefficient, so the 2, into everything in the brackets, and we get 18 minus 6y plus 4y is equal to 8. And when we simplify, we get minus 2y is equal to 8 minus 18, which is negative 10. And we find that y is equal to negative 10 over negative 2, which reduces to positive 5. Now we're going to sub the value of y back into our equation for x. And when we do so, we find that x is equal to negative 6. Therefore, our solution is negative 6, positive 5. At this point, I would imagine these examples are becoming slightly repetitive. We have now solved many of the same examples graphically, by elimination, and by substitution. And this is done on purpose for you to see that you do arrive at the exact same solution no matter which method you are using. Now we have 2 practice questions that we're going to solve by substitution. looking at both these equations, neither one is necessarily easier than the other. I'm going to solve for variable x from equation 1. From equation 1, we see that 2x is equal to 13 minus 3y, and when we solve for x, we divide both sides of the equation by 2, and make sure you divide both terms by 2. You get 6.5 minus 1.5y. Now we can sub that equation for x into the original equation 2. And we expand negative 3 into the brackets, and we find that negative 19.5 plus 4.5y plus 6y is equal to 12. Okay, simplifying, we get 10.5. Y is equal to 12 plus 19.5. And that ends up being 10.5y is equal to 31.5. And y is equal to 3. Okay, now taking that value of y, we can sub it back into our equation for x. And when we solve it, we find that that x is equal to 2. And the solution to the system of equations is 2, 3. And looking at the next practice problem, we can easily solve for variable y from equation 1. Moving the 3x to the right-hand side of the equation, we find that 2y is equal to 8 minus 3x. Now, to solve for y, we divide both sides of the equation by 2. My decision to solve for y and not x from equation 1 comes from the fact that I would rather divide an equation by 2 than by 3 because the decimals are nicer to work with. They're terminating, and you won't have any rounding error in your solution if you decide to not include all decimal places. It's worth noting that you can solve for this system of equations by solving for either variable x or variable y first from equation 1 or equation 2 and proceeding with the operations to solve for the system, and you will get the same answer as long as you use mathematically correct steps. Okay, now we take the equation for y, which is equal to 4 minus 1.5x, and sub it into the other equation, which in this case is equation 2. Now to solve for x, we expand the negative 5 into the brackets. Don't forget that negative sign, and you get 8x minus 20 minus 7.5x is equal to 18. Grouping like terms, on the left-hand side you get 0.5x, and on the right-hand side you end up getting negative 2. Okay, now last step to solve for x, we divide both sides by 0.5. Dividing by 0.5 is the same as multiplying by 2. You end up getting negative 4. Now we'll take our value of x is equal to negative 4, sub it back into our equation for y, and solve for y. When we solve for y, we find that y is equal to 10. And the solution to the system of equations is negative 410. In the last video for Module 4, we will use all of the techniques covered so far to solve application problems.